simple events, they join to give us compound events. Now let's take an example. Now if let's say I toss a coin, right, the outcomes are heads and tails, right? So this is actually a simple event. But what happens if I toss two coins, or if I toss a coin twice, right? So tossing of two coins, or tossing a coin twice. Mathematically, they are both exactly the same, right? Now, when I toss two coins, the outcomes are going to be, the all possible outcomes are going to be, the first coin, it throws a heads, the second coin, it also throws a heads. So HH now becomes my first outcome, right? In place of a single H, now H and H becomes my first outcome. Now, the first coin could still show heads, but the second coin could show tails. Then tails heads and tails tails, right? So now we have listed all possible outcomes when I toss a coin two times, or when I toss two coins simultaneously, right? Let's look at another compound event. Now this compound event, let's say, is a coin throwing tossing a coin and throwing a dice. Tossing a coin and throwing a dice. Now, a coin will have possible outcomes heads and tails, right? A dice will have possible outcomes 1, 2, 3, 4, 5, and 6, right? Now, when we both do both of these simultaneously or one after the other, essentially, when our experiment comprises these two singular experiments, then the list of possible outcomes is, we list all the outcomes of throwing a dice with heads first, and then we list all the possible outcomes of throwing a dice with tails, right? So h1, h2, h3, h4, h5, and h6, right? So these are the first set of outcomes. The next set of outcomes is going to be, you match all of these with tails. So t1, t2, t3, t4, t5, and t6, right? So there's a total of 12 outcomes. So the sample space has, this is the sample space, and the number of elements in the sample space, right, is equal to 12, right? Now, as the compound events, they become more and more complicated, right? The number of possible outcomes, it continues to increase, and solving the questions using compound events, it kind of becomes difficult. Now, let's say if we were to throw two dice, right? The number of possible outcomes, they become, the first dice shows a 1, the second dice also shows a 1, right? The first dice shows a 1, but the second dice this time shows a 2, and so on. 1 4, 1 5, 1 6. Now mind you, I'm writing 1 1 together, right? Actually I should be probably writing it like this, but just to make it faster and simpler, I'm just writing, so this is not the number 14, right? So this is the outcome 1 on the first dice and outcome 4 on the second dice. Okay, so we've got 6 like this, and then we got 6 1, sorry, we got 2 1, we got 3 1, 3 1, 4 1, 5 1, and 6 1, going like this, and then we got 2 2, 3 2, going like this, all the way until 6 6, right? So you notice that the number of outcomes is 36, right? The number of outcomes is, because you're throwing two dice, right? If you recall your permutations, then the first dice has 6 outcomes, right? The second dice also has 6 outcomes. So the total number of outcomes, right, or the number of elements in the sample space, is equal to 6 into 6, right, which is 36. Now you recall the previous examples we've done. Throwing of two dice, right? The first sorry, the throwing of tossing of two coins, right? So this is tossing of two coins becomes, tossing two coins had 4 outcomes, right? It had 4 outcomes in the sample space. Now the first coin when tossed has 2 outcomes, heads and tails, right? So first coin. The second coin also has 2 outcomes. So the total number of outcomes becomes 2 times 2, which is equal to 4, right? Then we had tossed a coin and thrown a dice, right? You remember there were 12 outcomes. Why? Because tossing a coin has 2 outcomes, throwing of a dice has 6 outcomes. So if you must do both, right, there is an and, you must do 2 times 6, which is equal to 12 outcomes, right? So this thing can get more and more complicated. Let's say we were to throw 3 dice, right? So the total number of outcomes then would become, so 3 dice, the number of outcomes becomes 3 into 3 into, sorry, it becomes 6 into 6 into 6, right? So 216 outcomes, right? Now let's say if there were a question, right, in throwing of 2 coins, what is the probability of getting at least one heads, right? So at least one heads in throw of 2 coins. Now in this case what happens is that at least one heads is actually equal to exactly one head, and it is also it also allows for exactly 2 heads, right? Now the case of exactly one head, we get HT, right? This is the outcome out of the 4 possible outcomes in the sample space. You would recall that tossing of 2 coins, the sample space equals HH, HT, TH and TT, right? Out of these, exactly one heads is this one. Sorry, this is HT and TH. So we have exactly one head in 2 cases, HT and TH, right? Now exactly 2 heads is in only one outcome, which is equal to HH, right? So because this is at least one head, so it is going to be a combination of this and this, right? Because you can either have exactly one heads or you can have exactly 2 heads, which means that the total number of favorable outcomes for this event is 1, 2 and 3, right? So when we combine both of these, at least one heads, at least one heads, this event will have HTTH from this event, from this outcome, and HH from this outcome, right? So the number of outcomes is 3, right? So the probability of getting at least one heads becomes 3 out of 4 possible outcomes, which is equal to 0.75, right? Then let's take another example. Now this time let's toss a coin and throw a dice, right? So this is again a compound experiment. Now in tossing a coin and throwing a dice, let's say we define an event A such that we get a heads on the coin and we get a number less than 3, right? So if you recall, all the possible outcomes in the sample space were heads 1, heads 2, heads 3, heads 5, heads 6, tails 1, tails 2, tails 3 and so on until tail 6, right? Now we are looking for heads on the coin. So all of these, so A will not have any of these, right? Once you get a tails, that outcome is ruled out. But a number less than 3 on the dice, right? It's 1 and 2 only. So A has H1 and H2 as the favorable outcomes only, right? So number of elements in A is 2. So the probability of the event A happening is 2 divided by there's 12 elements in the sample space, 12, which is equal to 1 by 6, right? Likewise, we could also define for, let's say, throw of 2 dice. So we define the experiment throwing 2 dice, right? And let's define an event B such that the number of outcomes, the total, let's say, total on the faces of the two dice is less than 4, right? Now in this case, the total, it will start from 2, right? Because the sample space in this case is 1 1 1 2 and so on until 1 6. Then it goes on 2 1 2 2 and so on until 2 6, and then it goes on until 6 1 and until 6 6, right? So recall that there were 36 outcomes in the sample space, right? Now we are looking for the total on the faces of the dice to be less than 4, right? So the number less than 4, let's start from here. So we have the number 2 right here. 1 plus 1 2, so this is a favorable outcome. 1 2, this is also a favorable outcome. Now once we go further to the right, it becomes 1 3, right? So 1 3 becomes 4, which is no longer less than 4, right? So we have to rule that out. Let's come to the next row. 2 1, that favors, that is a favorable outcome, but 2 2 equals 4 and not less than 4, and so on, right? So you go further down, you don't get any favorable outcomes, right? So what we end up with in the event B is 3 outcomes: 1 1 1 2 and 2 1, right? So the number of elements in B equals 3, right? So the probability of event B is going to be equal to 3 divided by total number of outcomes, which is 36, which is equal to 1 by 12. So there is 1 in 12 chance that the outcome that you will get when you throw 2 dice is going to be less than 4.